So today I'm going to talk about action potentials and graded potentials and the main differences between them. So before I get into the details, I just have to go over the structure of the neuron first. So as you can see, there is a cell body, there is the nucleus and the dendrites. One thing that we need to know is the axon hillock, that is where the cell body attaches to the axon, and axon goes down to the axon terminal. So the first thing that I'm going to go over is the location of each of these potentials. Graded potentials start at the dendrite or the cell body, where the neurotransmitters are sending the signal from another neuron. Action potentials, on the other hand, start at the axon hillock and send the signal down towards the axon terminal. So these two kind of potentials use different kind of channels to start their signal. Graded potentials have ligand-gated or mechanogated channels that are located on the cell body that respond to neurotransmitters or if there is some stretching on the membrane. Action potentials, on the other hand, have voltage-gated channels that they need to reach the potential in order to start their signal down the axon. So the strength of these potentials is the next thing that I want to talk about. Graded potentials have variable strengths depending on the amount of neurotransmitters that have reached the cell body or the dendrites. But action potentials, on the other hand, they are all or nothing. So it doesn't matter how strong the signal is, the action potential is going to be always the same. So if you want to compare this to something in real life, we can say that the action potential is like the speed of a bullet leaving a gun. And it doesn't matter how hard you really pull the trigger, the speed is always the same. Just like the action potential with the same strength. So another important fact to know about these two kind of potentials is their propagation patterns. Graded potentials are decremental, meaning that as you move away from their source, they're going to get weaker and weaker. Action potentials are non-decremental, meaning that when they start at the axon hillock, their strength doesn't decrease down the axon. So the important fact that we should memorize is the direction of spread for these two. Graded potentials are bidirectional, so they can go back and forth, but action potentials are unidirectional, meaning when they start at the hillock, they are always going to end up at the terminal and they are not going back. The next thing that I want to go over is the summation and how these two compare to each other. Graded potentials can have two types of summations. One of them is temporal, the other one is spatial. So the spatial one is from different locations. That imagine that there are different neurons that are attaching to the cell body from different directions. The temporal summation, on the other hand, is with time, which means how quickly they're sending neurotransmitters to the cell body. Action potentials, on the other hand, don't have any summation. And when you send one signal in an action potential, you need to wait until that one reaches the target, till you can send another one. And this is called the refractory period of the action potential, which is related to the refractory period of the voltage-gated channels. So the next two things that I want to go over are threshold and the function of these two kind of potentials. So action potentials usually have a threshold for their voltage-gated channels. So for example, if you're talking about sodium channels, we know that their threshold is usually negative 55 millivolts. Graded potentials don't have any thresholds. They only have a variable strength. The function of these two potentials is also different. Graded potentials are usually just to start gathering enough power to fire the action potential. So they're just kind of short distance. Action potentials, on the other hand, are long distance sending signals that need to hold their strength. Well, the last thing that I want to talk about is the polarity of these potentials. Each of these two can be hyperpolarizing or depolarizing, and it only depends on the receiving end neuron and its receptors on the cell body. It kind of doesn't even matter on the neurotransmitter that this neuron is going to send to the next neuron, because some neurotransmitters are excitatory for one and inhibitory for the next neuron. So you just have to see which part of the body and which kind of receptor we're talking about. But generally, if there is a neurotransmitter that is causing chlorine signals, chlorine atoms, and on the other hand, if we have a neurotransmitter that is causing sodium atoms to enter through ligand-gated ion channels, that neurotransmitter is going to be depolarizing for the receiving neuron. Well, I hope you guys enjoyed this video about the differences between action and graded potentials. And if you guys like to see more videos like this, please like this video and follow my page. Thank you so much.